A postulate in geometry is a rule accepted as true. Without proof. All right, and then there's three postulates right there on the bottom of page 7 that you're going to want to get in your notes. And the first one is, through any 2 points, there is exactly one line. Through any 2 points, there is exactly one line. Kind of common sense, right? If you got a point and you've got another point, isn't that 2 points? You can only have one line that goes through those 2 points, right? Period. Through any 3 non-collinear points. There is exactly one plane. And if 2 points lie in a plane, then the line containing those points is in the plane. And on the bottom of page 7, example number 3, identifying points and lines in a plane. Name a line that passes through 2 points. So looking at that diagram, can you name a line that passes through 2 points? Line N. Very good. Okay. What's another name for that line? Good. Line GH. And one more name for it. Line HG. Very good. Turn the page. 2 more postulates on the top of page 8. If 2 lines intersect, then they intersect in exactly 1 point. If 2 lines intersect, then they intersect in exactly 1 point. if two planes intersect? Then they intersect in exactly one line. Lines intersect at points. Agreed? Planes intersect at lines. Make sense? The front wall of the classroom is a vertical plane. The ceiling is a horizontal plane. Where the ceiling and the front wall meet, do you see that edge? That edge represents a line. All right? So where planes meet, they form a line. Where lines meet, forms a point. Got it? Questions? Okay, now we're going to start the next section. So flip on over to page 13, and you're going to start a new section of notes. So it'll kind of look like a new day. And the focus question for that section is going to be, how can I use the segment addition postulate to determine segment lengths? And if you turn to page 14 and look down the bottom, you'll see the segment addition postulate. And we're going to start with a picture of a segment. So let's get this segment on your paper. The segment addition postulate says that if B is between A and C, then segment AB plus segment BC is going to be equal to segment AC. This distance right here would represent AC, wouldn't it? Okay? So that's AC. So look, another way of saying that is the red piece plus the blue piece. Doesn't that equal the whole piece? That's the segment addition postulate. Could also say that AC, if you know AC and you subtract AB, what's left? BC. Very good, BC. And if you know AC and you subtract BC, what's left? A to B. Very good. It's up to you. I'll leave it this way with notes. In my opinion, notes are not you copying down everything that I write on the wall. If I'm writing something down and in your head you're going, that is common sense, you probably don't need to write it down. Okay? I mean, if I was giving you driving directions to get from here to the Chevron, you're not going to take out a notepad and write them down, are you? But if I was giving you driving directions to get to Long Dogger's Beachside, and there was 5 or 6 different turns, and you had to make a turn on this street, you might jot down a little note. Well, you would back in the day. Now you would just type the address into your GPS, and it would tell you how to get there, right? So that was a pretty bad example. But you get my point, right? They're your notes. So you write down what you think is important to you. You may realize after a couple weeks, I'm writing down too much. You can abbreviate your notes in a way that you understand. You don't have to write out every single word that I write out. You know, you don't have to write out with or between. I've told people in the past, take notes as you would text. You guys don't spell anything when you text, do you? Do you like a letter and 2 letters and a dash and a, right? So you can take notes that way. They're yours. Okay? All right, so today you're going to be using this segment addition postulate. And you're going to be doing problems that will look like this. So we're going to say that B is between A and C. AC equals 17. Let's do AC equals 14. BC equals 11.4, and you're asked to find AB. Now I'm going to tell you this now, and I'm going to end up saying it to you over 100 times this year. And that is going to be draw a picture. You're going to read problems in here all year long. And you're going to go, I don't know how to start this problem. Where do I start this problem? I don't know what to do. As soon as you tell yourself, I don't know what to do, I'm going to tell you, or as soon as you tell me you don't know what to do, I'm going to tell you to draw a picture. As soon as you draw a picture, it's going to clear everything up. So can you draw a picture of B being between A and C? You can draw a line, right? And on that line, can you put B in between A and C? From A to C is 14. And from B to C is 11.4. Does that make it a little simpler? So how far is it from A to B? 2.6, right? 2.6. That's the whole piece minus one of the smaller pieces. Gives you the other smaller piece, doesn't it? Small piece plus small piece equals the entire piece. Entire piece minus one small piece gives you the other small piece. In example B, S is between R and T. Find R to T. A little more complicated. Top of page 15. So now they're giving you the picture. And the picture looks like S is between R and T. So here's S. Here's R. And here's T. R to S is 2x plus 7. S to T is 28. And the entire piece, R to T, that's 4x. You're asked to find RT. And when they say find RT, they mean the distance from R to T. So what do you need to find out first? You need to find the value of x, don't you? Because doesn't this say that from R to T is 4 times the value of x? All right. So look at our equation. One small piece is 2x plus 7. So 2x plus 7. Plus the other small piece is 28. What do the two small pieces have to sum? Right, but in this case, doesn't the small piece, RS plus ST, equal RT? So that equals 4x. So now you've got an equation. You can combine like terms and solve for x. So 2x plus 35 equals 4x. Subtract 2x from each side. $35 is going to equal 2x. And then you're going to divide by 2. So what's x equal to?
17.5.
Still haven't found RT, have we? But if you substitute the 17.5 for the x, what's 4 times 17.5?
68. Wait,
Would you bet your life on it?
no.
You see these right here? They're called calculators, and they're used for calculating. What'd you get? 70, very good. R to T is 70. If R to T is 70, let's find R to S. Anybody? Are you sure? What's the real quick and easy way to find R to S? How about 70 minus 28? Right? What's 70 minus 28? 42. Does everybody have a calculator? Everybody, make sure you go get a calculator. I want to show you something on here. Do this. Take 5 and subtract 1 1/3. So here, we're going to type 5 minus type 1. See the button to the left of 1? Fraction button 1, fraction button third equals. What'd you get? 3 and 2/3. Very good. Does everybody know how to use the fraction button in the calculator and what fractions should look like on the screen? Okay, please use that button. Confused?
Yeah, I'm confused.
Okay, so clear your calculator again and type 5 minus. This is the fraction button, the A, and then B, C, right there. So you type 1, this button, 1, this button, 3, and in the calculator it looks like 1 and 1/3. So addition, subtraction, multiplication, division, anytime you see a fraction, most people don't like fractions, just let the calculator deal with the fractions. Okay? Now push the second button, the green button in the upper left, second, and push the bottom left button with the arrow on it. Behind it says F to D. And it took your 3 and 2/3. And what did it do to it? Turned it into a decimal, didn't it? How many places? What does your calculator say? Okay, so now take your calculator and type second. See the period button below the 2 on the bottom?
Yeah.
Fix. Push 2. Second, fix 2.
Oh, wow.
Did it change your answer to 2 decimal places?
Yeah.
Okay. So this calculator, you can tell it how many places to round. Second, fix. Now push second, fix 3. Second is the green button. Fix is right above the period. And then push the number 3. And how many decimal places do you have now? 3. So depending on the problem and what the question is asking, you can tell the calculator how many places to round it. Second, fix 0. Second, fix 0. Nearest whole number, doesn't it? That's rounding it 0 decimal places. All right, so use the calculator for your fractions. Use it to round. Got it? Okay, so your assignment for today is going to start on page 15. On page 15, towards the upper third of the page, you're going to do the check it out. Do you see it? Check it out. It's right below the 2 examples we just did. And you're going to do 3A and 3B. Then on page 17, six through 8. (14 through 16). And then answer the focus question. And check headline for homework.